So, good evening, folks. I'll be talking about injecting security into web applications at runtime today. So, how many of you here know about RASP or Runtime Application Self-Protection? Can you tell me what is RASP? Anyone? Oh, okay. Anyone else? What's your idea of a RASP? Okay, then that's my job to explain what that is. I'm a security freelance consultant. I do security engineering for Immunio as well as for Yardley at the moment. I currently research on runtime application self-defense. Other couple of security tools like MobileSurf, Synoptics, Node.js, Scan, etc. Then that's enough. Okay, so what's the talk about? So I'm going to talk about runtime application self-defense, or which is, or it's commonly known as RASP. It's a new term in the AppSec industry. Even our AppSec is new, so RASP is something like the new buzz in the industry. So I'll be talking a lot on monkey patching. I'll be talking about injecting security at runtime, a lot on Lexers, how to do tokenization, etc. What I'm not going to talk about is I'm not going to talk about something which is more like a fancy WAF, and I'm going to claim it as a RASP. I'm not going to do that, or old wine in new bottle. This is entirely different technology and thing. So for those who doesn't know about this particular technology, please use this talk as to set the expectation of what a RASP actually is. Because being in the AppSec industry, you will be hearing about, or you already heard about this particular term in defending your networks, defending your web applications, etc. The thing is that you need to know what exactly is a RASP and what exactly is not. So let's move on. So what are the common AppSec challenges these days? So people who manage application security know about these challenges. Writing secure code is very difficult. It's not easy. Even as a security engineer, I used to write a lot of code that results in LFIs, authentication bypass. I'm just being frank. It's difficult to write secure code, even though you know all the security things, or you behave as if like you know everything. It's very difficult, especially the logical ones. It's easy to write bugs. And most of the organizations, they follow agile development strategies. They have like, these days, people are using that particular model. I don't know why, but they are in love with the model. Every week, every day, new releases, new builds coming out. And it's the job of the security team or the application security team to make sure that the builds or the releases are secure. I don't know, like you have 10 apps in your company or 10 particular web applications or mobile applications, and you have to actually do release testing on each and every build. Because of this agile nature, it comes every day or every week. So it's very easy to introduce vulnerabilities or to reintroduce the vulnerabilities that are fixed. From the mobile space, the one thing that I commonly see is that the developers actually bypass a self-pinning, and the security guys find it, we file a report and they fix it. But it's not over. On the testing environment, they still use this bypassed code or the way of bypassing SSL. And the thing is that often in many release, it actually gets shipped into the production. So it's very difficult for the AppSec team to completely, cover all the scenarios on every and each release. We can only do a sanity testing. It's not really practical. It's really boring here. How do you test a single app every time, every day through all the logic? So that's one problem. And then there is other AppSec headaches like session hijacking. It is not a vulnerability. It's more like a issue because of design, because of the way in which your browsers are designed. So session hijacking means somebody takes somebody's cookie and put it and replicate the session. So it's not like a vulnerability, but it's an issue. It actually affects a lot of people. And another emerging issue is credential stuffing. If you follow this Have I Been Pwned, you can see a lot of big web services getting hacked, their database being breached, and these database with credentials or decrypted credentials are actually available in the black market. So few years back, what attackers does is that they actually target a web application, they do a brute force or a dictionary attack. And we know how effective that is. But these days, guys like Gmail, guys like Dropbox, etc. are breached. So they have a very large user base. So if the credentials are cracked and those are actually in the hand of black hat hackers, what they can easily do is they can use those credentials to do a brute forcing, which is more fine-tuned and which gives more success rate because of the fact that we are great people, we just reuse the password everywhere. So that's a basic problem. So these problems we cannot actually solve. But these are not vulnerabilities, these are actually your problems. So a lot of the companies which are actually getting hacked, or a lot of the accounts which are actually getting hacked are not via RCE or SQL injection. It's based on attacks like this, credential stuffing, because of the thing that you just reuse your passwords. So these are some of the challenges of AppSec. Let's see what is the state of web security. So these days, you never write a web application by writing a PHP code from scratch or a Java code from scratch. These days, to make you more lazy, or let's say to make you, more productive, you have frameworks or toolkits like Django, then you have Rails for Ruby, you have Express for Node.js, etc. So these frameworks, the nature is that they actually give you a set of APIs which you can use to build your web application. So that is the web frameworks, the state of web frameworks. Let's talk about the security in this. So most of these web frameworks, they actually come with some kind of inbuilt security features. So if you see, for example, I'll be talking today on Python. I mean, that's one platform where I have done my research on at the moment. So let's talk about Django. In Django, you have automatic CSRF token to prevent cross-site request forgeries. The thing is that in the past, people have to write their own CSRF validation logic separately to the framework to make sure that CSRF doesn't happen. But now we have Django providing this functionality. You don't have to do that. Just use the particular API and then it will automatically secure the post calls or whatever critical calls they are. Then we have templating frameworks. So in the past we used HTML, then we used dynamic substituted HTML, and now we are into templating, where you actually take a template and then substitute values into the template at runtime and then render the page. So because the frameworks are actually handling them using a standard set of APIs, what they can do is they can actually do escaping on the input and then provides you escape content. So which means you don't have excesses anymore, right? And same thing with the way of handling SQL. You now have ORMs. These ORMs are actually providing you a high-level APIs with which you can actually do multiple database operations like select, insert, update, etc. So these are safe. You are not writing, or your developers are actually not writing any more vulnerable code. These ORMs will handle that, right? That's what you think, right? So the main problem why security issues are still there is because people write bad code. You have the security features, you can write your own security features, you can use security APIs. But why bugs happen still? It's because either people don't know how to use these secure APIs, or because of misconfigurations, or because they write insecure code. So even though we preach a lot on security, it's at the end of the day, missions are not full. It's you who make it to behave like fools. So it's the people. You cannot put security into people. You can only put security into mission. You can preach, but there is a limit. So we actually saw that these frameworks actually provide some level of security, but are they really enough? That's what we are going to figure out. We have anti-CSRF token. The Django provided inbuilt anti-CSRF mechanism. The problem with that is it can be easily misconfigured, or it can be easily, or they may just not use the API. For example, if somebody want to write a REST server, you cannot actually put CSRF token on APIs that is used for a REST server, right? It's a stateless thing, so you cannot put that. People can actually replicate that code and use it in somewhere else, and a lot of misconfiguration. Not really a correct reason to say that. It's because of people who actually don't write good code. Anyway, forget about that. But let's come to templating. The problem with templating is that most of this framework, especially Django, it provides escaping. The problem is it provides escaping only in HTML context. So we all know that XSS is not really that simple. It differs. It really depends upon the context in which the data is getting interpreted. So the problem here is that if you do HTML escaping in some other context, it can still result in XSS. So it doesn't really solve your problem of XSS, but just that it will give you a layer of protection. I'll just show you a demonstration of how this works. I have a JS fiddle here. This is just a demo. This is just for demonstration purpose. So here, it's really visible. here there is two variables named user input and user input 1 and user input 2, which has to access payload. Your default templating engine will just do HTML escape, which means it just does escaping in this format. All your ampersand will be converted into the basic HTML escaping stuff. But the problem is, you can see this particular function, $#link.attr href is equal to escape HTML of user input 2. We are escaping the user input 2 and putting it into the href tag of an anchor. If you see the user input 2, it's JavaScript alert 1. Do you think HTML escaping is going to protect you? It won't, because you can see that it doesn't have any characters that will be escaped after HTML escaping. So if you click on this, you can still see the alert pop up. So it's all like context specific. Your framework, your templating engines provide some kind of escaping, but that's not enough. Another great example is ORMs. So you think that you use ORM, you are not going to write native SQL queries or manual SQL queries, which may have possible way of taking untrusted user input and resulting in access. But the thing is that even with ORMs, SQL injection is still possible. If you take the example of Rails, there is an entirely a site dedicated for Rails called Rails SQLi, which actually shows you the different possible way in which SQL injection can happen in the active records, which is the high level ORM used by Rails. These are some of the possible way. It has a very exhaustive list that contains the possible SQL injection in the APIs provided by this ORMs. Okay, let's go on. So there are other things. Remote OS command execution. Your framework doesn't offer any level of security. Remote code injection, no. Server-side template injection, session hijacking, verb tampering, file upload restrictions, and the list goes on. These things, your web framework, even the newest web framework, they cannot actually provide security. I mean, they are not immune against this. So the thing is that if you want to have security for this, you need to write code. So, but how many of the engineering team really write all the security code to make sure that such so and so attack doesn't happen? So they write code when somebody hacked them or some vulnerability happens, right? So then people know this. I mean, people who run the organization, they know the issues. So they thought that let's do one thing for these unforeseen issues. Let's use WAF. And will it solve that? Let's see. So the first WAF came in 1999, I think, almost 18 years of existence. Okay, before that I have a question. So how many of you guys use WAF in your organization? Very few? Really? Okay, people still use WAF. How many of you actually run it in defending mode? Really? No one? And you pay for it, right? Okay, fine. I expected at least 1 to 5 years. Anyways, people actually use WAF, but always in monitor mode. The problem is that it has a lot of false positives. That's the main problem. So I'll explain it why. Let's move on. Yeah, they all use blacklist, and being an application security guy, we know what blacklists are. So one day or other day they'll get bypassed. No matter how hard you put blacklist, one day or other day it will get bypassed. And the rule of thumb of application security is never to use blacklist, always use a whitelist. I mean, there are cases to use blacklist. I'm not blindly telling that, but for most of the generic thing, never use a blacklist. Let's look more into WAF. What a WAF actually sees. A WAF actually can only see your request, which is the complete headers, the body, the parameter, whatever you see in the slide, and even the response. So what WAF actually does is it detects attack, not vulnerabilities. So let's say you're doing a manual pen test and a particular parameter comes like this, x equal to script alert script. Can you just say that it's an XSS? Can you say that, confirm that it's an XSS vulnerability in the application? No, right? Because it's just an attack attempt. It's never an exploitation attempt. Or we are not really sure if an vulnerability happened or not. So the fundamental thing that you have to understand is WAF is used to detect an attack, not a vulnerability. So that's the reason why there is so much of false positive. If the user input contains some string that is actually in the blacklist of WAF, it just gets triggered and so much of false positive. And that's why people here still never run a WAF in defending mode. We are application security people and we pay we pay so much of money to buy products. But what is the point of looking into things that are actually happening? Let's say if an attack happened, we can just look and see, okay, the attack happened there. It got hacked here. Okay, nice. But what is the point of spending so much of money on something that doesn't really prevent the attacks or neutralize the attacks? Okay, moving on. We know it's blacklist based. They detect attacks, not vulnerability. And the WAF has no application context because it can only see your request and response. Nothing more than that. It doesn't know what actually happens inside the application, whether a payload got bypassed or whether it got executed or exploited. It did exploitation inside the application or not. It doesn't have any idea. So WAF is a layer which is actually standing behind or standing in front of your application server. So the request come to WAF, the WAF will analyze, and if it sees something fishy, it will just block the request. Otherwise, it allows it to pass through the application server process it, send back the response, and some WAF even do analysis on the response. Let's say there is absolutely no point in that. So the thing is that, let's say there is a payload, an SQL injection payload which bypassed the WAF. It bypassed the WAF and went into the application server, got executed, and the response is something like MySQL query error or something like that. And if the WAF sees that in the response, it just blocks the response. Do you think that is going to solve anything? What is the point of defending once after the attack has happened? So these are some of the problems which I see with WAF. I'm not saying WAFs are bad, I'm saying it's time to move on. So there is another problem. So this is a famous problem most of the organization face. You pay money for, again, I don't want to talk about that. Let's leave it. You use WAF and thinking that they will add security to your environment or your enterprise. But they in fact used to downgrade your security. So how many of you know about perfect forward secrecy? Okay, people know about it. For those people who don't understand PFS, it's more like a feature of SSL where even if your private key is leaked, if let's say some attacker actually captured your HTTPS traffic and some other day your private key is leaked, he can actually use that private key to decrypt the traffic. So PFS makes sure that even if the private key is leaked, he won't be able to decrypt the previously captured SSL traffic. That's what PFS does. So because of that particular nature, it also has a feature that it does not allow you to do MITM. So how WAFs work is that they actually ask you to give your private key to them so that they can decrypt the HTTPS traffic, they do re-encryption or just pass the traffic back to your application, depending upon how you configure it. So because of this nature of PFS, like there are some curves like ECDHE, the WAFs cannot actually support PFS. So if it sees a traffic which contains this particular protocol, what it does is it just blindly doesn't do anything about it. So if your application server is using that, your HTTPS traffic is not protected. Not a great thing. So some WAFs recently started using a reverse proxy to solve this. It's like doing this. Anyway, again, another reason is that you heard about the bug Heartbleed. So Heartbleed is a really critical bug that actually allowed an attacker to leak out your private key. So if we get the private key and if we captured the previous traffic, he can decrypt your data in theory. So again, no, nothing. So organizations actually want to move into PFS, but still your security product is not allowing you to do that. Again, there is a headache of SSL decryption and re-encryption. It's not really a big deal, but it's a deal. When you have crypto like ECDHE, which is actually very expensive in terms of computation. So if you do that things, it takes time. So that overhead is there. Let's forget about that. We have like the modern hardware. And TLS 1.3 is coming. So the draft is already there. Around draft 18 is still being reviewed and something like that. The RFC will come soon. That's what I hope. If you see the elliptical curves, it supports a lot of curves. And organization really want to move into these curves. It's really required to have a, minimum level of transport security these days. You don't want to use any SHA-1, you don't want to use any of those sorts. So this is the recommended suite provided by TLS 1.3. People will be moving. So I don't know what is the future of there. Okay, so we have to evolve. We can do much better than this. It's around 18 years. Think about that. AppSec has grown. It's around 18 years. What have we done? So WAF, it's more like an attack detection, not a vulnerability detection and prevention. That's what WAF does. And then came SAST and DAST. SAST is typically your static code analyzer, which can actually find vulnerabilities by analyzing code, but they can actually have a lot of false positive. The same thing with DAST. They actually do your web scanners, typical web scanners. I'm not naming anyone. They can also do good depending upon how good their fuzzing payload is. They do a black box fuzzing on the parameters and then give you a response. Still, lots of them are actually false positives, and you won't be able to, precisely identify this thing. The next generation of DAST is actually IAST, or Interactive Application Security Testing Platforms. So they are actually more precise. They can actually do precise vulnerability detection, all those things. So that's actually very closer to how a RASP works. But RASP has a different purpose. So if you see in the figure, the SAST, DAST and IAST, it's purely used by application security team for penetration testing to find out vulnerabilities in your web application. The first one is for defending attacks. Now let's come back to RASP. So RASP, or Runtime Application Self-Protection, it can detect attack, which is what your WAF does. It can even prevent or neutralize attack. So WAF only blocks attack. It cannot neutralize attack. I will tell you what's the difference in there in the coming slides. Then there is precise vulnerability detection. It is precisely in the sense it will point you exactly in which line of code the vulnerability occurs. And some added extras. We'll see what exactly those are. Okay, so into Runtime Application Self-Defense. It can detect both attacks and vulnerability, zero code modification and easy integration. These are some of the characteristics of a typical RASP, or these are things you should actually look into when assessing a RASP. I'm telling you, it's going to come soon. There are around 20 RASP vendors in the world at the moment, I think. They're just only 20. Everyone in their early phases. So these are some of the criteria. So I'm just here to set the expectation of what a RASP should really do. So there is no hardware requirements. You apply the defense inside the application. You have exact code level insights, fewer false positives or very negligible false positives. Inject security at runtime, no use of blacklist. So these are some of the features of a runtime application self-defense system. So, and let's think about it. We see WAF work in front of your application. It doesn't have any application context. So which is the ideal place to put security? So if you ask me, the ideal place to put security is inside the application. Just a layer above where the application core functionality responsible for executing bash commands or executing SQL, etc. is placed. So it should be a layer between your HTTP request processing API and the core of the logic, because that's a place where we get the user input, right? Okay, we have more interesting stuff. This is just for your information on assessing a RASP. There are different types of RASP. There is the one that actually use pattern matching and blacklist. That's not a RASP. Then and there, that's not a RASP. People will claim that's a RASP. That's not a RASP. It's just a fancy WAF. What's the point of using all this hooking, all these things, and then put a blacklist there? Then there is dynamic tainting. It's really good. The problem is tainting means a lot of performance. So if you have a very large application, you cannot really deploy it. It provides you rock solid security, very minute false positives, but the problem is performance overhead. I don't see any vendors who really implement this in practice because of the performance issues. Then there is virtualization and compartmentalization. It's good, but the problem is it's actually targeting only Java, mostly JVM. That's what I have seen. So these RASPs are actually good to target your JVMs. These are actually not working in code level, but it's more like your Docker container or your containerized security. That's what it does. I haven't done more research on that. That's not the, that's not what I'm going to talk about today. Now what I'm going to talk about is code instrumentation and dynamic whitelist. The WAFs that do that. It's good. The problem is that the advantage of WAF is you just put a WAF and it just says it will protect attack against all your application stack, even written in Java or Python or whatnot. Whatever is running on HTTP stack, it says it will protect. The problem with RASP is that it is specific to framework. It can support Python application written. It doesn't support Python. It supports frameworks written in Python. It doesn't support Ruby. It supports framework written in Ruby. So it's specific to frameworks. The whole point of RASP came because your web frameworks are available today. Few years or couple of years back, there were no web frameworks. So it's difficult to implement something like this. But now we have web frameworks, and they have standard set of APIs for handling everything. So we can actually use this technology. Let's move on. This is the focus of the research, what I'll be showing you today, or the work that I have done. I have implemented a RASP by API instrumentation and dynamic whitelisting. I tried to secure a completely vulnerable web application written in Django, written in Tornado with 0 code change. So this is the one important feature. This is what developers will love. You don't have to write security code. You don't. Yeah, we'll come into that. And these are some of the vulnerabilities that we'll be preventing today: SQLi, RCE, stored and reflected accesses, DOM accesses, and few of other abstract challenges like verb tampering, header injection, file upload prevention, protection, path traversal, etc. And I will also share a glimpse on what I'm doing at the moment, the future research. Okay, before going into this, let's actually talk about 3 important things of a RASP by API instrumentation. So the 3 things are: one is monkey patching, the other one is lexical analysis, and the third one is context determination. So how many of you know about monkey patching? How many developers here? How many JavaScript developers here? 1. I heard that monkey patching is a way of writing code in JavaScript. That's what most of your framework does. So for those people who doesn't know what exactly monkey patching is, I'll just show you a quick demo. So the resolution is very great. So you can see, let me copy this. There is an anchor tag which on click will call the function alert we love you. So you can expect a simple JavaScript alert box, right? But if I click this, it says, one second. Okay. Yeah, if you click this, it says we don't love you anymore. The thing is, it actually write it as we love you, right? That's what you're supposed to see, right? But what came is we don't love you anymore. That's what is the basic idea. You hook a function, you overwrite its functionality at runtime. That's what we do. So you need to understand this concept. Monkey patching actually allows you to patch the functionality, patch the internals of a function and replace it at runtime. Next, let's go back to the presentation. Lexical analysis and token generation. If you ask me, I have seen this during my BTech days, and I really thought that why in the world I have to study about this thing? I just can go and write program, right? Why should I actually learn about lexical analysis and how compiler works, that too of C compilers? I just couldn't get it. But this thing actually really started to make sense when you actually try to do some security things in an applied way. It really makes sense. Maybe I wish that I could have been taught in a better way. Like, instead of saying it has so many applications, they could have told me something like this is one of the applications. I could have loved it at that time itself. So lexical analysis is one other important thing that we use for this particular RASP. So it's just simple that you give a syntax to it. It actually analyzes, splits all the syntax and say what exactly is what. Is the slide visible? Kind of like. Okay, fine. So you can see that if you pass something like if x greater than 3.1 into a lexical analyzer, it will actually tokenize it and give you something like if is a keyword, bracket, this one is a bracket, then x is an identifier, again greater than is an operator, 3.1 is a number, right? So we actually use this concept. I'll explain why we actually need this. One important nature of a lexical analyzer is that by design it says that, theoretically it says that if it sees a character that it cannot understand, it will just quit there. Or if it sees white space or comment, if it sees white space or comment, it will just ignore that. But for our purpose, we need to include those two things as well. I'll just explain why we need that. Let's move on. Let's take a simple example. So you have a input like int value equal to 100, semicolon / value equal to 100. If you pass it to a normal lexer, it will tell that int is a keyword, value is an identifier, equal to is an operator, 100 is a constant, semicolon is a symbol. But the custom lexer that I have wrote, the idea is that I actually need it into the finest granular level. I need to know what exactly goes in there, especially the things about comment. It really matters a lot when you talk about context. So it will be, if you pass it into my lexer, it will be int keyword, For the space, it will say it's a white space. And again, the only difference is at the bottom, the / value is 100 is considered as a commit. So that's what this lexer does. Okay, so let's move on to one more thing. The next thing is context determination. So if you see an HTML like that, you give it to your browser. This is what your HTML parser does. It actually determines the context. So in the bottom, you can see a head tag, and then there is a heading. That's a context. So it's a DOM pass DOM tree. Now you can actually see which are the contexts here, right? It doesn't really tell you what are the contexts, but it is represented in that way. HTML head, body, h1, 5 frame. It's a syntax tree which is actually created after the HTML parsing is done. Let's move on. Let's try to understand what is the problem here. So you always try to understand the root cause and then you solve it, right? That's the way you should be doing things. You just don't try to apply some level of security at a higher level. You find the root cause and fix it. So the problem is that the root cause or the mother of, no, not the right type. So the problem is that the code injection vulnerabilities happen because your interpreter cannot distinguish between code and data import. It is pretty common in WebSec, AppSec, it's pretty same. In everywhere, even in the system security where you have exploitation happening, your buffer overflow, whatnot. The basic problem is this: people cannot solve this thing. I mean, your machines cannot understand what is code and what is data. It just considered everything as code or data depending upon you give input to it. So if you can solve that, if you can solve the problem solve that particular problem, you can actually solve all the code injection problem. So that's what we are going to do today. Let's see how we can use this technology to prevent SQL injection, remote OS command execution, stored and reflected accesses, DOM access, etc. So consider an SQL query. This is one of the very basic SQL query. Select star from user input, where user input is the place where the input comes from the user, which is untrusted user input. And you have an API inside your, let's say, in your web framework that execute this SQL statement. It can be something like SQLite 3.cursor.execute this thing, right? And then we have, so what we essentially do here is, I told about monkey patching, right? We use the same concept here and patch the cursor.execute function and extract the SQL query. We hook it and extract, and we don't do anything. We just extract the arguments to the particular API. That's the hooking phase. The next is the learning phase. We apply the knowledge we had earlier. We, instead of learning the exact SQL query, because if you want to learn SQL queries for your application, it will be like 1,000, especially those Java application. I don't know, internally it will convert your queries into millions and millions of SQL queries for performance or whatever reason. So you don't want the exact queries, but you want a tokenized representation. So you convert select star from logs by applying lexical analysis to generate a particular rule. This is actually your whitelist. So it will be select keyword, again, the same alt lexical analysis. And let's say if the next time, if an attacker try to input something else, select star from logs and drop table admin, you can see the lexical analysis rules have changed, right? So that's a clear indication that this is not supposed to be a particular query that needs to be executed in that particular context. So I'll just make it a little bit clear. So the rule, the dynamic whitelist rule that we generated for select star from user input is keyword whitespace, operator whitespace, keyword whitespace string, right? And even if I change from select star from logs or select star from history, the context won't, the rule won't change, right? Because at the end of the day, it's all string. The moment I add an SQL query, the structure changes. The part in the red in the bottom is a change structure. So we can actually precisely detect SQL injection. We don't really want to look into some payloads and see if that has a signature of an SQLi, let's block it. We can precisely detect it. Let's see a demo. That's the interesting part. So here I have an application. Can you see it? I cannot. Okay. So this is a pure vulnerable application written in Tornado web framework using Python. Okay, so we're talking about SQL injection, right? There is a login page, simple login functionality. You give the credits. It says login success. if you give the wrong threads, false. Let's try to put some payloads. Oh, let's do the vanilla, the favorite one for the bug hunters. Okay, it says admin login success, hello admin. So basically SQL injection is there, and this is underlying code. Yeah, so you get the username and password from the user input and then pass it to the SQL execute statement. Select star from users where user equal to this thing. Let's try to solve this thing using RASP. So I told you that if you are using a RASP, it should not ask you to do code change. So here is the same application, same vulnerable application, which is protected using a RASP. The only change in this is this one, import RASP. So you have to import the particular module. That's the only change there. There is no other code change. There is no other function being called or anything. Just import it. It will apply security into your application. It will inject security into your application, like the title of the talk says. Let's see. So let's run this application. Demo sucks. Okay. So the protected application is running on. Let me just make sure that few other things required for this is running in the background. Okay, it's running. All good. So let's go to the protected version of the same thing. Same application. We'll go to login and we'll try to do login using admin. Success. We'll try to give a wrong username. It says login file. Now let's try to inject something. Let's try some simple payload, not even a valid SQL query. Let's do simple payload, and you can see that RASP blocked the request. So what essentially happened here is, if you just go back to my dynamically generated whitelist, you can see something like this. So this is an rule for the particular context, and if that particular, you can see that it ends with a string, single quote and string. So if the rule for that particular context changes, it will never allow you to execute the query. So you are actually in fact detecting it. So the thing is that I'm not showing it, but since I have access to where exactly the query is supposed to execute, I can actually tell you which line number contained the vulnerability. So you can precisely identify where the vulnerability occurs, as well as you can precisely block it. Let's try with a valid thing. Let's see if it works. So if you try anything else that follows that particular syntax, it will still allow you. But the moment you put something like this, it just blocks you. So precise blocking instead of just putting some blacklist based blocks, right? Let's move on. Okay, let's talk about OS command injection. So this is another thing. Same logic here. Untrusted user input come into the API that is supposed to execute bash commands or shell commands. This is one of the API that we hook into. I'm just showing an example. You have to hook into all the APIs which are responsible for this issue. So I'm just hooking os.system and extract the arguments, that is ping -c3 127.0.0.1, and then doing lexical analysis on that to generate the whitelist. So this is the whitelist generated. This is a custom lexer that I have wrote. So the ping is an executable, then there is a white space, -c is an argument dash, white space, 3 is a number, and white space, and if you note in the bottom, 127.0.01 is identified as an IP or domain. I'll tell you why it's important. Moving on, if an attacker tried to inject a command like this, you can see that the structure really changes. It changes to, from IP or domain, there's a white space, and is a splitter, then again, and a white space, cat is another executable. So the structure completely changes. If you see, the rule for the context is this, and it will even allow you to put an IP or a domain name or whatever, depending upon the logic you write. It can actually allow that, any type of IP or the domain name. But the moment it tries to escape out of the context, the token or the rule for the particular context changes and it will detect it. Let's see another demo. So I'm just speeding things a little bit. I have like a lot of demos. So I'm not showing the vulnerable one. Let's show the vulnerable one. I'm executing this command, and you can see that it did a ping. And if I try to do and ls, see, it just got executed, right? So what I'm going to do is I'm going to do the same thing in the protected version. By this time it have learned the rule. I can even give let's try it, and let's try to give something like and ls. It blocked the request. So you got the idea, right? Okay, let's quickly move on to another one, XSS. So this is a different problem. You have a template like this where user input goes in, and if you want to solve XSS here, you need to actually escape based on the context. So this is an API used by Tornado. We'll actually hook the API instead of doing all this lexical analysis. The problem is that for OS command execution, it's perfectly fine because you have a very few lines of command, but HTML of a page is very large. So if you do lexical analysis on that, it's a very big cost. So in that case, we actually use parsing, and then we precisely detect the context, and we provide escaping in the context instead of doing a simple HTML escape for that. Let's see a demo. So here's a search bar. If I do something like this, if you go and view the source, you can see that there is a two places where it's actually getting reflected. One is HTML context, and another is a script value context. It perfectly escaped it in both contexts, which is context specific escaping. That's one thing that a RASP can do. Let's move on quickly. The same thing with DOM access. I'm not covering it. It's an open source already available project called DOM Purify. They are doing it. Let's not cover that. There are a couple of other things like preventing web tampering, header injection, file upload, etc. So it's pretty straightforward. You hook into the request API, then you learn the verbs and generate the whitelist. The next time you see a verb which is not in the list, you block it. It's pretty straightforward and simple. Rather than your WAF just blocking all your option and trace request. Same thing with header injection. Your WAF has to look for all the possible encoded combinations of %0a and %0d. But RASP doesn't need to do that. It just need to check out for the particular thing that will possibly break the context. So that's that. Moving on, we have file upload protection. The same thing. When somebody uploads a file, you hook into the API which is responsible for writing the file, extract the extensions, and generate a whitelist. And then based on that, if any other files come with a different extension, at the end of the day, you can actually block it. I'm not showing the demo because of lack of time. Another thing is path traversal. So think about the amount of payload or the blacklist that a WAF needs to have to block this. It's too much, right? There is so many type of escaping, encoding, all those things your WAF has to handle. But we don't actually have to do that, because at the end of the day, whatever bypass you put, it just get de-encoded or decoded into the original form, that is ... /.. So what we do is we hook the io.open API, which is responsible for reading the content. We find out the directory from where it's actually allowed to read and what are the extensions. And if we block anything that goes out of the directory. I'll just show you a quick demo. So let's see this. This is a classic example of your path traversal, right? For a RASP, it can actually let's try to give that, and it just blocked it. So if you see the rules, you can see that this is a directory from where the particular API in the particular context is allowed to read, and this is the extension. Since there is no extension, it's empty. So that's the way you actually harden your web application precisely without any false positive. Let's move on quickly. These are some of the things that actually currently I'm doing research on. I don't have much content to present it, but I have some interesting result. We'll be publishing it in some other or the next version of the talk or something. So these are the RASP advantage. It's really accurate, precise vulnerability detection, code level, even the stack trace is available. It's not based on heuristics, so zero or negligible false positives. It doesn't downgrade your security. Not much performance overhead because we don't have to, encrypt and re-encrypt your traffic, so and so. And it's very easy to use. Pip install the package and import the package. That's it. Security is injected. So, and the best advantage is you can deploy something with the money you pay for. It's not about you buy something and put it on monitor mode. Now you can actually put it on defending mode. Yeah, these are some of the ideal characteristics of a RASP. You can actually refer the slides for that. And that's all, folks. Thank you. And these are the folks I would like to actually thank you, my colleagues in Iminio and the wonderful Yardley security office teams. Shout out to you guys. That's all. Thank you, folks. Yeah, if you have any questions, you can just.
Before taking the question, I would like to check Abhishek and Suraj, are you here? Abhishek and Suraj from Microsoft. Okay, we can take the question. Vaibhav, you want to shout out or you want a mic?
Yeah. So the thing is that for any RASP to work, not any, but the one which I have designed, it's more like you need to learn it properly and tokenize it. So the effectiveness of a RASP depends on how you actually tokenize and learn the thing. So if your lecture logic is not so great, this is a POC. Maybe in this particular context it may get bypassed. I haven't checked, but that's a very basic POC. If you look into commercial products, they have like alternative approaches which are more or less similar, but in a more better way so that such kind of issues won't happen. So the strength of the technology is about how you can actually learn your application. It's more like how your SQL parser work, right? How do I put it? Like if you write an SQL query and if you have an apostrophe in that, you will escape it, right? In real world. So where exactly is the problem coming there? Because we are hooking the same API and we get it, we parse it exactly the same way your SQL parser parses, and it's not escaped, it's escaped already. So that issue won't come. So more or less it's like we parse it exactly the way your parser parses it. Any other questions? Yeah. See, this is more like a research at its early stage, more like a proof of concept. It's not a production ready tool or something like that. I'm actually working on it to come up with a release in future once my research is done. So again, it's very, very basic proof of concept. You can see it's implemented on Tornado, and you know how many people use Tornado. So it's a proof of concept, and I work for a RASP company to say. So the thing is that I actually want to set expectation of what a RASP is and how it works. People should know. I mean, you should not really fall for marketing blunders. You should know how it works. That was the intention of the talk. More about telling how the algorithm works rather than releasing a tool. Yeah. See, the challenges is more like what we see there is not about code injection thing. We can actually solve this very effectively. We are actually trying to even do advanced stuff like preventing session hijacking. So how will I identify the session come from you and not this guy? So such things are even difficult for humans to analyze. We are trying to find a possible solution or the best possible solution to prevent this. So the motto that we carry is that we don't need a half solution. We do it only if we can do it perfectly. So that's what we are trying to do, but these are the challenges, some of the challenges. Yeah, it's pretty much like this. I mean, for Java, you have to import a package. For Ruby, you have to, again, do a gem file. For Node, you have to npm install another thing. So I told you, like, it's framework specific. So you install that, it's protected. So it's technology agnostic as well. The commercial product has that, but that's not the point of the talk. Let's not make it commercial. Yeah. Yeah. Yeah, that's what I'm telling. We are actually monkey patching all this APIs, like os.system, your SQL execution API. So even before the command got executed by the parser, we get it. So we actually create whitelist from from hooking the API and then generate the rules. So based on that, we can actually do that. If you know the concept of monkey patching, you import something. After everything is imported, you can overwrite all the function, almost everything. And then you can apply security. That's why you don't need to write your separate security logic. It's all based on monkey patching. There a question, yeah. Yeah. Mm-hmm. No. Yeah, so that's a point I'm telling you. No matter whatever ORM you use, internally it will convert it into native, the lowest possible way, the DB driver way of executing it. So no matter whatever ORM you are using, we hook at the lowest level. So whether it be whatever, so we hook at the DB controller layer. So we can exactly get the queries, which is in the exact representation of standard SQL. See how it works is you call an ORM API, right? The ORM API, how it works is internally it convert it into SQL query and then execute it. It depends upon how you design it. Yes. Yes. So it depends upon where you hook. You can actually hook at a layer upper. So in Rail, we have, but not here. This is just a proof of concept, just to make people understand what the algorithm is, how this technology works. We don't want to put into ORM. Let's go into low level. That's what I think. So the thing is, for ORMs, we have two hooks. Let's say there are people who use ORM to write things, and then there are people who does not know to use ORM. So they write the native thing. So it depends upon where you hook. You can hook anywhere. Yes, it is there. Not really. That's the point of what I'm trying to say. So the thing is, the Django temp escaping, if you use it, it's just pure HTML escaping. If you do HTML escaping in JavaScript context, that's a pure XSS. That's possible. See, that's what I told you. Like, if you see most of the templating framework, by default, either you have to write code to, specifically mention this is the context. So let's say if you find an XSS in your web application, you are using a templating engine. Now, you are not like a small company, but a big enterprise. How much does it take you to review the code, find the exact point, go there and fix an JS encoder and escape it? What is the cost of that? That's something that we are trying to solve. So I have worked a little bit on Django. The thing is that by default, it actually allows you to do escaping in HTML escaping mode only. Otherwise, you have to write your own custom escaping functionality and you have to inject that particular escaping mode into the templating API. That's how you do it. But there are intelligent templating frameworks like the Google's Closure, if I remember correctly. They have context specific escaping. So few others doesn't have. Yeah. Yes, sir. Yeah. I don't recommend the conventional method. No. Because you see, nobody here. No, I'm not talking about that again. Let's leave it. That will hurt some people. So fine.
Fine. Ajeen is here, and yeah, it's our Ajeen, right? So
we'll catch off stage. Yeah.
Yeah, you can take that one last question anywhere, okay, and you can have more questions. So